Hi and welcome. Today we are going to look at constraint optimization, the maximization and minimization problem using the Lagrange, okay? And this is under the economic application of the calculus of multivariable function. So, let's start. Please take your book, calculator and pen so that we do this together. So the first question says, a firm's unit capital and labor costs are at 1 Ghana cedis and at 2 Ghana cedis respectively. The firm's production function is given by Q, okay, is equal to 4LK minus L squared. Are you with me? And total input costs are fixed at 105 Ghana cedis. Find A, the maximum output levels of K and L, that was capital and labor. B, the maximum output, and C, the marginal product of labor and at the maximum. Okay. Now, to do this, it's important you know that. Look at this. They say unit capital. So, unit capital is how much? 1 Ghana cedis. And unit labor is 2 Ghana cedis because they say respectively, meaning 1 cedis goes for the first one and 2 cedis goes for the second one. And they said the total input costs are fixed at 105 Ghana cedis. You know, a capital is an input and labor too is input. Okay. Capital and labor are both inputs, isn't it? So to know this, you are going to you are going to create the constraint function yourself by saying that what? 1 times number of capital, 1 cedis times the number of capital that you introduce, plus 2 cedis times the number of laborers employed should be fixed at 105 Ghana cedis. That's what we mean. Should give us 105 Ghana cedis. I hope you are following. So this is the constraint function. Do you get it? And this is the objective function. This. Are you with me? Now, in order to optimize the objective function, okay, in order to optimize the objective function, the first thing you are going to do is to set this constraint to 0, or you set it equal to 0. How do we set it equal to 0? We are going to have it k, 1k is the same as k, okay, plus 2l, plus 2l. You bring this 105 here. When it crosses the equal to sign, it was a positive, right? As soon as it crosses the equal to sign, it becomes what? Negative. So you're going to have negative 105 equals what? It's equal to 0. We set the constraint function to be equal to 0. I hope you are with me. Then after doing that, are you with me? Then you multiply it by what? Lambda. Okay, when you multiply it by lambda, then you add it to the objective function to form the Lagrange function. Okay, so in order to form the Lagrange function, you multiply this part, you multiply it by lambda, okay, then you add it to the objective function. So you are going to have the objective function plus lambda times the constraint function. That's how it is done. Are you following? So when you simplify this, you're going to have what? 4lk minus L squared plus, now lambda times k gives you what? Lambda k, isn't it? Lambda times 2l gives you 2 lambda l, isn't it? Or lambda 2l. Then lambda times negative 105 gives you negative 105 lambda. So we've simplified it. Now the next thing you are going to do is to take the first order partials. Okay, you take the first order partial derivative of each of them and you set them equal to 0. Okay, so to do that, when we take the first order partial derivative of L, okay, when we differentiate Q with respect to L, we are going to have it QL. Okay, so QL is equal to, now we are differentiating this, okay, let me say this, we are differentiating this, okay, we are differentiating this with respect to L. So to do that, there is an element of L over here, isn't it? L exists over here. So what you do is that you subtract 1 from the exponent. Okay, you first use, L is exponented to 1, right? So you use it to multiply this and then subtract 1 from the exponent. When you subtract 1 from the exponent, you have 1 minus 1, which is what? 0, right? And L exponent 0 gives you what? 1. So 4 times 1, 1 times 4 times 1 times k gives you 4k. So this tends to this. Then when you go further, when you differentiate L squared, this 2 should multiply the L. So 2 times L, do you get it? Then you subtract 1 from the exponent. That's how we differentiate. So we have L exponent 1, because 2 minus 1 gives you what? 1. So we have 2L exponent 1. And 2L exponent 1 is the same as what? 2L. Do you get it? Now, there is no L here. So since no L exists over here, when you differentiate this, it becomes 0. So we don't write it anymore. And then here, there is an L here. And the L is exponented to 1, right? So when you use that one to multiply, you have 2 lambda L. When you subtract 1 from the exponent, you have 0, right? L exponent 0 is 1. And 1 times 2 times lambda times 1 gives you what? 2 lambda. So this has been what? Differentiated, or the derivative of this is 2 lambda. So that, and there is no L here, right? So when you differentiate this, it gives you 0, right? Then you equate it to what? 0. So that's the first equation. Now the second thing you do is to also differentiate Q with respect to K. Okay, to capital. So let's now differentiate with respect to capital. Now to do that, I hope you're with me. To do that, what we are going to do is, we are differentiating with respect to K, okay? So lambda K. So when you differentiate, this is exponented to 1, right? 1 minus 1, 0. K exponent 0 is 1, so you have 4L as this. Now there is no K here, so this becomes 0. There is a K here, right? When you differentiate this, it's exponented to 1, right? When you use 1 to multiply, you subtract 1 from the exponent, it becomes 0, right? So K exponent 0 is what? 1. And lambda times 1 gives you lambda. That's why we have lambda here. It's equal to, you know, this gives you 0 because there's no K there. This also gives you 0 because there's no K there. So you equate this also to 0. Okay, you are going to be equating each of the partial derivatives to first order partial derivatives to 0. Are you following? Then, that's equation 2. Then the next thing you also do is to differentiate Q with respect to lambda. So there's no lambda here, this also becomes 0. There's no lambda here, it becomes 0. There's lambda here. When you differentiate this with respect to lambda, okay, I'm coming. So now let's differentiate this with respect to lambda. When we do that, you have 1 minus 1, isn't it? And it gives you 0, so you have K. When you differentiate this, you get K with respect to lambda. When you also differentiate this with respect to lambda, are you with me? You are going to have what? Lambda is exponented to 1, okay? Then you subtract 1 from the exponent of lambda, you get 0. Lambda exponent 0 is 1, so you have 2L as your answer. Do you get it? So it becomes 2L. When you also differentiate 105 with respect to lambda, 105 lambda with respect to lambda, you are going to get minus 105. Okay, then you also equate this to 0. So we have 3 equations. Are you with me? Now to solve these 3 equations, you can solve the 3 of them simultaneously using your calculator straightforward, or, so I'm going to use the 2 methods, so kindly pay attention. Now, look at this. Equation 1. Equation 1, we have what? 4k. Let me show you how to use the calculator for that. You have 4k minus 2l. You have to be very careful, okay, plus 2 lambda equals 0, isn't it? Then the second equation, when you look at the second equation, there is no k, so you say 0k. I want to write them so that they balance, okay, 0k. Then there is a L, right? So you say plus 4L. Are you following? Plus 4L. Then you have lambda plus 1 lambda, okay, plus 1 lambda is equal to what? 0. Okay. And then when you go to the third equation, is there any k? Yeah, there is a k, so 1k. Okay, there is 1k, sorry. And then there is L also, so we have plus 2L. Are you with me? Then we don't have lambda, so plus 0 lambda, plus 0 lambda, because we have no lambda in the third equation, so plus 0 lambda equals 105. You have to bring the constant to the other side. It's a constant. It has no variable attached to it, so you have to bring it to the side. So you see that you have 3 simultaneous equations. So take your calculator. Now look on your calculator and look at where they've written mode. Click on mode. After clicking on mode, you see EQN at 5. You see a place they've written EQN, so click 5. Now when you click on the 5, they will display some 4 equations. The first one is 2 variable simultaneous equation. The second one is 3 variable simultaneous equation. The third one is quadratic equation, and the third one is a cubic function. Okay, or yeah, the quadratic polynomial function. Okay, but we need the second one, because the first one is used for 2 variable simultaneous equation, and the second one is used for 3 variable simultaneous equation. So there are 3 variables here, k, l, and lambda. So we are using the second one. Okay, the second one is a 3 variable simultaneous equation. So you take the second one, so you click on 2. So after doing that, you see something will display in form of cells, or in form of matrices form, or something like that. So don't press anything. So look at this. What's the coefficient of k? The coefficient of k is 4, so press 4 and press equal to p. Then what's the coefficient of l? The coefficient of l is -2, so just click -2. Okay, then you press equal to sign. What is the coefficient of lambda? The coefficient of lambda is 2, right? So you just press 2 and press equal to sign again. Then what is the constant here? 0, so you press 0 and press equal to sign again. You see that the cell will now shift down to A2, right? So when you come to the next one, you press 0, the coefficient of k here is 0. Make sure they balance, k, 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 l, 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 lambda, lambda, lambda. If they do not balance and you made any slight mistake, you get wrong answer. So be very, very careful. So what's the coefficient of L? 4. Then you press equal to. What's the coefficient of lambda? 1. You press equal to. What's the constant here? 0. You press equal to. Then you come to the third one also. You press 1. You press 2. Positive 2. Then you press equal to sign. Then you press 0. You press equal to sign. The constant is 105. Be very, very careful. When you press equal to, you press it again. You see that it gives you x to be 175 over 3. It says x is equal to 175 over 3. So this is your x, L is your y. The one you write first is your x, the one you write second is your y, and the one you write third is your z. Okay, so you get k to be equal to, since k is x, you get k to be equal to what? 175 over 3. Isn't it? 175 over 3. Then when you press the equal to sign again, to give you y, which is L, to be what? 70 over 3. 70 divided by 3. And then you press the equal to sign to give you z, and z is your lambda. Okay, so it gives you -280 over 3. Is it over 3? Yes. -280 divided by 3. So that's the answer. But if you are not using calculator, you can go straight, okay, to create equation 4. And how did I create this equation 4? I made lambda the subject from equation 2, okay. I made lambda the subject from equation 2 by lambda is equal to -4L. -4L. Are you with me? When I made lambda the subject, what I got for lambda, which is -4L, I fixed it here in equation 1. So I have 2 times -4L. And 2 times -4L gives me what? -8L, right? So -2L plus -8L. Do you get it? It will give you -10L. So that's what brought the equation 4. That 4k minus 10L is equal to 0. Then I got my equation 5 also from this, because I've already blended these together, the equation 1 and 2 together to make equation 4. So in equation 3, k plus 2L, when you bring this here, you have k plus 2L equals 105. So that's what forms equation 5. So you can solve these simultaneously. Okay, 2 variable simultaneous equation. So when you solve them simultaneously, just this and this, when you solve it simultaneously, you get K to be 175 over 3, just like we got here, and you get L to be what? 70 over 3. I mean, this is two variable simultaneous equation. If you wanted to use the calculator, you would have used the 1, not 2. Do you get it? So, we got L to be 70 over 3, which is 23.33, K to be 175 over 3, which is 58.33, and lambda to be negative 2AT over 3, which is negative 93.33. Are you following? Now, lambda being negative means that whenever you get lambda to be negative, only if and only if you use the plus, okay, not minus. If you use plus, are you with me? I'm speaking in relation to what I've used. And you got lambda to be negative. What this means is that one, like if there is an increase of 1 in this constant, the constant of the constraint function, if there is an increase of 1, it means that there will be an increase of approximately 93.33, okay, in the objective function. That's the meaning. There will be an increase of 93.33 in the what? In the approximately 93.33 in the objective function, if there is an increase of 1 in the constant of the constraint function. That's the meaning of that value you've gotten over there. Okay, but the question just asked us to find the maximum level of L and K. Okay, so that's the answer to it. So B, question B says we should find the maximum output, isn't it? So to get a maximum output, you recall the equation. Okay, you recall the objective function. So when you recall the objective function, you are going to substitute what you get for L, okay, and what you get for K, what you got for them, into it. So when you substitute, you are going to have 4L, which is 70 over 3 times K, minus L square, and your L is what? 70 over 3, right? Square. So when you simplify this, just this part, you get 49,000 over 9, minus, this also gives you 4,900 over 9. And that gives you 4410 over 9, okay, which is 4,900. So the maximum output level is 4,900 units, okay. It's good you write units. If no unit of measurement is given in a question, like kilogram, like this, like that, you attach units to it, okay. So units. Then question C says we should find the marginal product of labor at the maximum, isn't it? So to get a marginal product of labor at the maximum, the first thing is to find the marginal product of labor. Are you with me? When you find the marginal product of labor, you see this was the function, isn't it? And this was the total product, right? So marginal product of labor means you should differentiate Q with respect to L only. Are you with me? So when you differentiate Q with respect to L, you are going to have what? 4K minus 2L, because we are differentiating with respect to L. So you have 1 here, right? When it multiplies, it still remains same. You subtract 1 from the exponent, you have L exponent 0, which is 1, so it becomes 4K. And this, you use 2 to multiply the L, so you get 2L exponent 2 minus 1. So 2 minus 1 gives you what? 1. So you have 2L exponent 1, which is 2L. So marginal product of labor is 4K minus 2L. So to get a marginal product of labor at the maximum, are you with me? What you are going to do is to substitute the maximum value of K and the maximum value of L into it. Okay, so marginal product of labor maximum, max, have you seen that? So that gives me what? This times this is 700 over 3, and then this gives me 140 over 3. And when you simplify, you get 560 over 3, and it gives you 186.67. Okay, so that's the final answer to this. Okay, you can write units since it's quantity, it's product. Okay, units. So that's the end of this. Thank you for watching, and you can share the link to any of your friends who would like to watch or who really want to understand more about this topic. And do well to actually to also subscribe to my YouTube channel so that you can get more videos from me. Thank you so much for watching.